So I spent a career in industry and at West Liberty University. Well, I spent 34 years there. I received my bachelor's degree while I worked there. I worked in maintenance and in heating and air conditioning. And so I had a lot of different roles there. But eventually, after 34 years there of doing all that, a position at Belmont College came open that I had previously worked out some internships with them. So I was on the advisory board, so a position came open. They offered that position to me. I applied for it. And it just so happened that it was time for me to retire from my career at West Liberty University. So I came to Belmont College and I taught for 5 years, and I developed the HVAC program with a lot of developed partnerships. I kind of brought my network with me, so a lot of the people that I worked with, they wanted to be a part of the educational process. And so I came to Belmont College and taught for 5 years. And after 5 years, there were some changes in a couple of the directors, and so they merged two areas and made that the industrial trades and offered the position to me. They asked me to replicate what I did in the HVAC side into the all the industrial trades, which includes welding, heavy equipment technician, building preservation and restoration, which little known. We have one of the few programs in the country, one of 2 or 3, where we restore historical places to their original. And so it's kind of an architectural program, and so that's part of it. We're doing drones, and we're also developing a safety program. But that was my, all to being director. And the HVAC program, we were actually on an OUE's campus in a dungeon, in a closet. And we kind of outgrew that right away. And so they made space in an old Polaris dealership for the HVAC program, and we've outgrown that as well. So we're in the process of building an $8 million facility.
So how's that program grown, student-wise? Numbers?
There
Your HVAC program.
were 7 students when I started, and we carry about 30 students a year. So,
A lot more than that.
yeah.
What was the first year you started again? So how many years ago? 7 to 30 in how many years?
5 years teaching. I went from 7 students to 30 students. And so there are some ways that we did that. We have pathways and partners. So like I said, I kind of brought my network with me, people who wanted to be involved in the educational process, and those were contractors and companies, manufacturers, representatives. And so one of the things that we did was we created some pathways. In Ohio, there are programs, and they have career navigators. And so we connected with all those career navigators to so Ohio, and each county, they have vocational schools. And a lot of the students don't necessarily want to go to a vocational school and to not be connected to their high school. And so we provided an opportunity where they can come for welding, heating and air conditioning, and heavy equipment technician for 1 day a week. So that introduces them to these trades. And with HVAC, they're able to get their EPA 608, and the Environmental Protection Agency is what governs what we do. It's the license that, so we offer those 12 points. They need core and type 1, which really doesn't matter, but we end up giving them their universal license, which works out really well. And that works into the CCP program, the College Credit Plus. And so those students that originally started in that high school program have come over into the College Credit Plus, where they can and walk into our own courses while they're still in high school. And so those are some of the pathways that we've done. And so we developed partners. A lot of them are local. The contractors, our advisory board is very active. And so they developed scholarships specifically for HVAC. And so heating, ventilation, air conditioning, and then we put a /R, which is refrigeration. and I'll talk about that here in just a minute. But so we develop not just local, regional, but national and international partners that want to be a part of what we're doing. And so we do work with the area STEM and career navigators in all the high schools. And I know that there are a couple of our new partners that actually came here this week. And so I was very excited about that.
Have you guys started exploring doing apprenticeship level programming?
Yes, part of the 12-point program, there are pre-apprenticeships.
Okay.
And so we're working with the building preservation and restoration. In those lists of points, there wasn't anything that actually lined up for that.
Mm-hmm.
So what we're going to do is establish our own criteria and add a pre-apprenticeship to that, and that'll add up to their 12 points.
That's cool.
Historically, it was for students that were in jeopardy of graduating, so these 12 points allowed them to be able to graduate. But what it did also is attracted them into what we were doing. A lot of what you all do is, maybe I'm not correct, Eric, but theoretical. There's a lot of heavy science and math and everything, and what we try to do is more on the applied side, where a lot of, if you come into our lab, you'll see HVAC equipment with ductwork on it and everything. Those are all student done. That's everything the student does. So we just built a pole barn for our heavy equipment program, and so through a grant we have some rooftop equipment. Our students are actually going to set that up, fabricate the ductwork, and they did the heat load calculations, and so they're actually going to fabricate that and put it into that building. And so every time there's an opportunity for our students to engage in something practical, that's what we try to do with them. And so the other thing that we're working on is articulation agreements with area high schools with some of our programs. So we want to be able to give them course credit for the things that they've done, because what we really want to do is create easier pathways. The the on-ramps into our programs have to be easier and to get into. There are some students we may need some remediation that we can work with. I think we're okay with that. So that's kind of where we were, and then Intel came in to the picture. And when they started with Intel, they started breaking the state of Ohio into groups. Well, Belmont became part of the Ohio University group, and we started the ASCENT ecosystem. And so creating pathways for those educational opportunities that lead to great careers. And so with Intel, when they came in, obviously you all know that one of the biggest things that they do is clean rooms and semiconductors, which Belmont College doesn't do anything that level, especially like you all do here at Ohio University, which is just absolutely incredibly impressive to me. And so all of your staff that I've met here, I've been absolutely amazed with, and I appreciate the opportunity of being involved here. And so we couldn't offer that. But what we did say is that we can train the technicians who work on the equipment in that. So Intel, we contacted the Intel, and they had the plant manager of the Phoenix fab that is going to be moving to, at least at that time, moving to the New Albany site. So they zoomed into our classroom and they spoke to our students about what skills sets that they need, what knowledge they need to work on the equipment that is in that fab. So we listened to what Intel told us, and so we developed a certificate, a one-year certificate to assist in providing technicians for that. And so with some support from Intel and our advisory board, we put together a one-year certificate, which I'll show that to you here in just a minute. But so moving forward with our educational tracks at Belmont, we have a one-year certificate in HVAC. So all of our associate degrees students will go through the one-year certificate. So they'll they'll finish their first year with a 1-year certificate. And we moved that around. So what we did, we do have thermodynamics, the fundamentals of thermodynamics, piping and installation, basic electricity, motors, and power systems. Yes, we teach all of that. But what we also incorporated into the 1 year is the forced air and sheet metal and AC systems maintenance. So why did we do that and make that specific for that? Because those two skill sets actually apply directly to one of the first jobs that an HVAC technician can get. So one of the first things that you would do is learn how to fabricate ductwork on top of a furnace, to install that, and to do the trunks and runs. So that student would be able to assist on a team to install a furnace into somebody's basement and learn to fabricate ductwork on a commercial rooftop unit as well. And the other one is the AC systems maintenance, and that is air conditioning. That's doing maintenance on it. You know, you drive your car, after 3,000 miles, you need to get the oil changed on it. Well, there are specific things that need to be done on a heating and air conditioning system. And some of you may have maintenance agreements on the ones that you have in your house. And so they have a lower level tech that will go out to the job. They will shut the unit down, lock it out, tag it out, clean it, inspect it, turn it back on, make sure it's ready to go. So those two things are just real heavy skill sets that they would need. And then after they graduate with their first year, they can actually go to the capstone. Now, typically capstone is at the end of your college career, but because it was easy to work with in the catalog, it was already a course, so we just put it in between first year and second year. And so our students, they take a capstone class over the summer, and they also have a employment component with that. So we have all of our companies that we work with, they work for them for the entire summer, and they come back 1 day a week for a Thursday evening class. And one of our really good partners, some of you may or may not have heard of Sheets. They're incredible. They're a gas station, and if you love coffee and all your stuff, you can go and get some of that. It's not Starbucks, but what we did working with them, so they take our students for the summer. They pay their per diem, put them up in a hotel. They're building 30 new stores in the Columbus market. They're going into Dayton, Cincinnati, Cleveland, Detroit, and Indianapolis. And so our students assist them. They install the rooftop equipment, fabricate the ductwork, install a freezer or a cooler, and that's their experience over the summer. And they get paid $24 an hour. And I know this is kind of funny because it's our region, but we had students at the end of that summer come back to school riding Harleys, bigger pickup trucks, and I was like, oh my goodness, because they're
maybe you're lucky they are coming even back.
Yeah, that's true. And when they get hired at Sheets, it's more closer to $30 an hour. And so we're providing that opportunity for them. And so that's what we did, was restructured. But we also are building a warranty program. Our president asked us to be the first program out of Belmont College to offer a warranty. So we had to develop a mechanism in order to do that. And so one of our partners is HVAC Excellence at ESCO Institute, which is the educational component of our industry. They have a national conference once a year for educators, which we participate in. And they've developed a series of micro-credentials, and we've embedded that into our curriculum, so they get these micro-credentials at all, on top of what their curriculum is. And yes?
Why you call it micro-credential? Shouldn't be just credential?
Well, they're smaller, so like the EPA 608, I guess it is a credential, but we've embedded it into the curriculum. So they get their 1-year certificate, but yet they also, if they pass a test and they demonstrate that they know what they're doing in the classroom, they can get a certificate from them, a credential, and they can even get a thing if they want on their uniform, a little insignia. But it shows that they demonstrated the skills and the knowledge base in order to you know, to do those series of tasks. Yes?
So how much of the curriculum right now is focused on the building automation systems and things like that? Because I assume like with Intel and everything, it's going to get a lot more automated and
Yes,
complicated.
I'm working towards that. I'll show you.
I will.
That's the part I'm trying to get to, because that's the part that I'm like really excited about. And and then we moved on to our 2-year associate's degree, and that is a lot more technical. We specifically go after, you know, different areas of the industry, and we teach troubleshooting and the science behind some of that. So I want to ask y'all a question. While we're getting ready for this, does a refrigerator make things cold? I know a lot of you are scientists, and you probably understand all that. But what about all of you? Does a refrigerator make things cold? And you don't count either. Yes.
I think it's probably more removing the heat.
Absolutely. So the refrigeration process, to me, is kind of like a miracle. It uses a substance that when you change its state, you actually absorb or reject heat. And so that's the refrigeration process. So my grandkids, they know that when they open the door, they don't hear, hey, you're letting all the cold out. No, they hear, you're putting all the heat in. And because that's what we're doing, we add heat. And so that's what becomes really important, is to understanding thermodynamics, and that it's not just making things cold, it's about understanding the science behind it, that we're actually removing heat. And we can control the change of state. Like, does anybody know what temperature water boils at?
Depends on the pressure.
Huh?
It depends on the pressure.
It depends on the pressure. I know, this is not the crowd to ask these questions. Typically at sea level, at standard conditions, water boils at 212 degrees Fahrenheit or 100 degrees Celsius. However, if you go to Mile High Stadium where the Denver Broncos play, water boils at 203 degrees Fahrenheit, and then if you go to Mount Everest, water can boil at 167 degrees. Why is that important? Because we see that as we change pressure, we can change the temperature, we can change the boiling point of any substance to what we want it to do, and we can manipulate it in the refrigeration process. And so we can change the boiling temperature of water when we're pulling a vacuum to get all the impurities and air and non-condensables out of a system when we're doing it. But that's the science behind some of that. But there are other things in air. The study of air, psychometrics, there is heat, and there is also humidity. And so that becomes real important inside of inside of a clean room. Why is this?
Get the little keys pull down screen.
Yeah, there we go. Oh, yeah. Oh, okay. So when Intel came and talked to us about what is in a clean room, there are things that we have to take care of. And so it's very important inside there that that whole environment is taken care of and it is controlled. Temperature, humidity, and the pressure in the air that's being sent out into the space. And we also have to do micro-contamination control. So one of the things that we got part of this whole thing is a vacuum system. It's about, what, $113,000. And so each of the station that somebody's working out with their bunny suit has a vacuum on it, and so it draws that silicate and all the stuff that's in there into this vacuum system and makes sure that none of that stuff gets involved in the process. And so with air, we add air into a system when we environmentally control the temperature and the humidity, but we also have, when we extract it, we have to make up for that. So there's specialized filtration that's on there, and so we have makeup air handlers, and so we have to introduce air back into. And so we are teaching make-up air units with economizers, and what's called a DOAS unit, dedicated outdoor air systems. Yes, this certificate was developed for Intel, and so we put their name, we put clean room technology on it. But this certificate actually is a certificate in advanced ventilation, understanding psychometrics. What is in air? What do we do with it? How we control it? And the systems that operate that. And so it will work in a hospital, in a surgical center, and in a system, in a campus as well, in schools. So we have to recirculate air, and we humidify it. We have to control the humidity in the building. And the equipment that we use are fans, filtration, heating and cooling coils, and building management system control, and tertiary chilled water systems. So normally, when you have an air conditioner that you may be familiar with, we remove the heat out of the air and out of the return air, and then we send it back into the space at a design temperature of 55 degrees. So with chilled water part of the system, we remove the heat out of water and pump that water to each of the units that are in there instead of a ventilation system, or it could be part of it. So, so this is the process and what Intel asks for in this. So what they've asked about is first principles to applied fluid dynamics and heat transfer, statistical analysis, fundamental control systems, building management. I'll talk about that. Water quality, which we developed developed a certificate for water quality management. Air quality, that air has to be clean inside of a clean room, because it's called a clean room. And so the filtration of that, vibration analysis, project management, and so industrial HVAC overview, high-level construction technology, all this kind of stuff. So why does this not look like what it looks like?
It's a man.
It's a mess. No, I want to go to another, I want to get out of there. Okay, sure. Yeah.
The very first one.
So we developed the clean room certificate, and it's called a one-year certificate, but you either have to have some advanced knowledge of air conditioning and so it's part of a 3-year program, or with our partnership with HVAC Excellence Institute, they have a 100-question exam that talks about refrigeration, thermodynamics, and components and everything. If they could pass that exam, we would let them come in here with some experience in the trade. But it's applies to any building. The education and training received for this certificate applies to any building that has advanced ventilation controls, equipment, and such as for hospitals, surgical centers. We talked about all that. I just thought we could.
Okay, that is the.
Cue Jeopardy music. Okay, so this program is, there's an overview in safety in clean rooms and introduction to semiconductors, and we're not developing that wheel. So that'll be taught curriculum that's already there. So safety is very important. So we added a OSHA 30. We have OSHA 10 in our associate's degree. We added OSHA 30, but the other 18 hours are going to have smaller credentials that they can get, like rigging and cranes, or there are several that we list that they can make up those 18 hours. Hydronic systems and pumps, they pump a lot of water. So we're working with a national manufacturer that, or a group of manufacturers with all the pumps and everything. So not only will they learn how to design the gallons per minute and how it fits in the hydronic system and all the things that go with that, and to tear it down and to work on it's a hands-on applied class, and for hydronic systems and pumps. And then we're actually doing a specific math for building science class, which is a lot of psychometrics, heat load calculations, and being able to figure all the things that will be actually in a building. And then blueprint project management, and this is specifically for HVAC, so they know how to start a process of managing that whole project. And so putting the whole thing together with cost, the amount of people that they need to do the job and everything, and so that's part of that. Blueprint reading for HVAC. Controls in, it's actually 3 semesters, controls in circuits and commercial environmental systems and predictive maintenance and analytical tools. So HVAC has changed for the longest time. It never changed. Then all of a sudden, it is the fastest changing industry out there. And so this is what we used to have, and you would take this and connect it to the system, had a high side and a low side to be able to see the pressures. And these gauges tell you the pressure and each of the types of refrigerant that is inside that system. You can see it's boiling or condensing temperature. And but every time you took this hose and connected it to there, the refrigerant that is in there, and some of that is very specific in order to remove the correct amount of heat, got put into these hoses. And that's one of the things that the EPA did not like, and they said, you need to stop doing this. And so the industry developed, catching up to the rest of the world, Bluetooth control. So you download an app, you hook this onto the port that is on the unit, and you take the temperature probe and you connect it to the temperature line, because not only do we need to see the pressure and the temperature of that refrigerant, but you also need to know its temperature above its saturation point at one point, and then below its saturation point at another one. And then we have to also measure airflow too. So these are new ways of dealing with this. So the EPA has come out with CO2 and M1, which are new regulations. So the commercial world has been regulated quite complicatedly right now, but now it's moving down into the residential world, and so we now have to do all of that in a residential furnace. So the new technicians are going to have an iPad. They're going to have to connect to the furnace and the air conditioner, and then they're going to have to set the static pressure on that unit for the region that it's in, and in order for it to be compliant as of January of 2023. And so, and while I get some of these other things out, Dad, did you have yours? And we're working with international controls.
This one's ready to go.
Okay, we're working with an international company on controls. So our new building, we want it to be a living learning lab. And so when they come into the building, the technicians or the students, they're going to see everything exposed and what it's doing. And with this program, they're going to be able to go into a room with a unit here and have a screen here, connect to it, and manipulate it and watch it happen in real time. And what is really nice is it has like a 30-minute default, so it'll go back to original settings so the students don't mess it up, which could be easily done. So, that's all building automation. And so all now on campuses, we want to look at everything. Not just the space temperature, but the static pressure that's in it, how much airflow is going in, and being able to control all of that as much as we possibly can. We have sensors on there to control the CO2 that's in the building, and with people breathing. And you know, you ever notice at the end of the afternoon, people are falling asleep when they're having a lecture? Well, it may be because there's not enough airflow being moved around, those air exchanges. And so we want to make sure that there's fresh oxygen in the room for people to breathe. And so we want to be able to teach that connectivity world, the IoT of the industry to these students. And so they live in that environment while they go out into work, into the world that they're going to be working in. And some of those diagnostic tools that we use. And so the industry has changed. Back in the day, everybody just went and fixed things that broke. That's called reactive maintenance. And so when we go and clean an air conditioner on a set time, ASHRAE has a standard 180 that if you follow that for each specific type of equipment, you can prolong the life expectancy of that equipment. It's called preventative maintenance. But now, there is a whole new world that technology has given us to, and it's called predictive maintenance. We can actually predict when a piece of equipment is going to fail, and so by setting benchmarks, and then in a timely manner, like a month, depends on how critical a piece of equipment is, a month, 6 months, a year, and go back and measure some of those things. And we can also do that in real time with building controls. So one of the things that we do is thermal imaging, infrared. So I can see all of the heat coming out of each one of you. And I'll maybe let you play with this, but you know, you can't see me, but let's see here. You can see my handprints on here. So you know that I was there because of my heat signature. And so we use this, like in a panel box where the circuit breakers are, we can look on that and see if there's any high amperage draw, the heat is growing. We can look at a motor to see if the motor windings are out of temperature or bearings are too hot. So we can use this in diagnostics. And
We used to use them with the fire program all the time.
Yeah.
Yes.
Our fire students use them constantly.
I used to, believe it or not, in former life, what my uncle did, he had infrared inspection. So we used to go and use these, and I worked for him for a few summers. I got to go up on the Sears Tower in Chicago and actually be on the roof because he was looking for heat loss in the building. Awesome job, but at that day, it was this monster thing that he had. It was just enormous, and now there's these handheld.
I have them stacked on a cell phone.
Yeah, the one that's on your cell phone is even better.
And you know what I heard once, and I don't know if this is still an issue, but people were using them on their cell phones. You go to an ATM, and then the person behind you could tell what keys you punched.
oh no.
Use gloves.
We use them with our fire students to play hide and seek. We would take the kids.
Oh my goodness, that's
We would
awesome.
take the kids into the burn building with all of the windows and doors shut and turn them loose with that and have them try to track other students and find them up on the second floor.
Oh my God.
Yeah, it was cool.
And this wiring has insulation on it. We can measure the insulation value to see if like a compressor or the motor is going bad. So like, when you're making chips and your business is depending on $1 million inventory every single day, your system has to operate. It's critical that it has to operate. And this one here is a vibration meter. So as things turn, they heat up or they're out of alignment. This can tell if the vibration is in sequence. And I have one more. Yep, lost it. Okay, so this here can go around the shaft, and so we can do laser alignment with these tools, and this is a shaft alignment tool. So when you have two things that are connecting together, they have to be aligned correctly. If not, that piece of equipment will fail sooner than it's expected. So, building automation, the Internet of Things, and predictive and diagnostic tools is a class that we're going to have also. And so being able to train our graduates to work in the Intel fab or anywhere else that has some kind of critical or sophisticated ventilation. And so that's kind of, in a nutshell, I guess, what we do.
How do you convince the old guard to go back and learn the new stuff? Not that I'm having to do that with anybody.
Well, I can tell you that it can be done.
Okay.
Because I'm an example of that. And you know, back before the EPA regulated refrigerant, you had a compressor that was overheating. They would get a drum of refrigerant, turn it upside down, and for the liquid to come out and spray that compressor. Yeah. And so now all of that is regulated. Yes, there are some, and with all these new changes, it's good to have them put with a younger technician who understands all this. And so they can go and teach the things that they know, and then the young person can help with them getting acclimated to this new stuff. But yeah, there are some people. Ed, you experienced that with AEP.
Oh, yeah, we used to hire linemen, but we had a 10-year period where we didn't hire, so we were bringing in new linemen, and the older guys, well, we'll just, make them dig every hole and do everything by hand. But what the new kids came in were computer skills. So coincidentally, we introduced new, computers in the trucks. The old guys, they just grabbed every young kid that we hired and said, "You're my computer expert." And then, the old guys were looking for the young guys to teach them. So it
Hopefully
wasn't.
they learn. Yeah, I mean, 'cause we have a whole bunch of new construction going on here right now, and we have HVAC, and it's a lot like administrative and things like that. You know it's working well when you don't notice it.
Yeah.
We've been noticing it a lot. So the problems are like, it's a very simple thing. We're in Southeast Ohio. There's a lot of crap in the air. And so they put pre-filters on our air handling units, and they weren't checking the pre-filters. And so the systems kept tripping because of the pressure differential.
Yep.
And so we were losing all the HVAC and our fume hood exhausts, which is really bad. So, and they weren't monitoring it. They weren't watching the BAS, they weren't watching anything. They were just, so it's like, we need to have a way to institute continual training. That almost needs to be a requirement to maintain licensure or something, because the systems change so quickly.
Yes, yeah. And one of the things I didn't mention, we hired somebody through workforce development that teaches these certifications to existing contractors, technicians. And so we've identified that as a weakness in the industry. And so like the new refrigerants that are inside are flammable, or they're slightly flammable. So they're within that margin, but a few ounces is one thing, but when you're putting several 10, 20, or 50 pounds of that refrigerant on a rooftop, now you have to be able to tell when that's, or in a confined space, when it's leaking. You have to have ventilation to exhaust some of that refrigerant. So there's a whole new world of things that have to go with the safety of some of this new stuff. And so we want to provide that to the existing technicians that are out there to be able to teach those sort of things. But yes, it's an ever-evolving world, and that's why HVAC excellence is so important, because they're the ones that are out there, they're connected to the EPA, and they're connected to all these changes that are going on, and they're the ones that are instructing the educators to help instruct the workforce. And so, just like connecting all the dots.
That same thing, it's not just in HVAC, I mean, it's in other areas. You know, I spent 27 years in the union, and yes, the old guys are incorrigible sometimes. But just like you said, I'm seeing that, hey, if we can educate the young ones, and the new equipment comes in, has the latest technology. The old guys are a little bit lost, and they have to admit that, hey, these young guys are what we need, and it's just changing. So but it's in every field.
Yeah, you could tell it was a good transition when the old guys were bringing the donuts in for the young guys.
Helps level out.
Rather than shaming them, and the young guys bringing in donuts. Here's a donut, now show me how to do this over here.
Or don't tell the others that I don't know how to do that.
Yeah.
Any other questions?
Good job.
So.